Good morning, student. Let's start today's class. In today's class, we are going to discuss about oscillator. Okay. Now, what is oscillator? Okay. Oscillator is a device that generate oscillation. Oscillation means like vibration. Okay. In oscillation in physics, you can or in your physics class, you have studied about the oscillation. Okay. Oscillation means like a pendulum or like vibration. Okay. So that oscillation or frequency. Okay, that means oscillator is a device which generate oscillation or frequency. Okay, you know, in our communication in our communication, okay, communication circuit, there is need of uh, what high frequency. Okay, what is carrier frequency or that carrier frequency is a high frequency. So that carrier frequency generated by this oscillator. Okay, so this oscillator is widely used in radio and TV transmission and receiver and computer also and radar also. Okay, so this oscillator is widely used in these devices. Okay, now the oscillator may produce sinusoidal or non-sinusoidal oscillation. Okay, so oscillator which produce sinusoidal wave is called harmonic oscillator. Okay, and which produce sawtooth or square wave, these two waves are non-sinusoidal waves. Okay, which oscillator produce these two waves or non-sinusoidal wave, that is called relaxing oscillator. Okay, so there are two type of oscillator, one is harmonic oscillator and one is relaxing oscillator. Okay, now let us see the sinusoidal oscillator. Okay, type of sinusoidal oscillator. Okay, there are sinusoidal electrical sinusoidal electrical oscillator can be two types via damping oscillator, that is damping oscillator, and on-damping oscillator বা sustained oscillator. Okay, so what is damping oscillator? Okay, the electrical oscillator whose amplitude goes to decrease with time are called damping oscillator. Okay, that here you see this is the damping oscillator waveform. Okay, in this damping oscillator waveform the frequency decreases, okay, with the time. Okay, the frequency decreases, sorry, the frequency, not frequency, sorry, the amplitude. Okay, frequency, this is frequency, this is amplitude decreases with respect to time. Okay, so this is called damping oscillation. Okay, now the obviously the electrical system in which these oscillations are generated has loss. Okay, due to that loss the amplitude decreases. Okay, so loss and some energy is lost during each oscillation. Okay, further no mean are provided to compensate the losses, and consequently the amplitude of the generated wave decreases gradually. Okay, it may be noted that frequency of oscillation remain unchanged. Okay, frequency is unchanged here. Okay, since it depend upon the constant of the electrical system. Okay, so you see, it says that whenever this system, this damping oscillator system have some losses, due to that loss the amplitude of the oscillator, okay, of the amplitude of the sinusoidal wave generated from that oscillator is decreasing gradually with time. Okay, and now the second one is undamped oscillator. Obviously undamped means there is no amplitude decreasation. Okay, so the electrical oscillator whose amplitude remain constant with the time is called undamped oscillator. This figure shows undamped oscillator. Here the amplitude not decreasing, the amplitude is constant with time. Okay, so here the amplitude is then since the amplitude is not decreasing, so this system this system has no loss of energy. Okay, so it should and if if there is some loss of energy, let's say some loss of energy also is there in this system. So to compensate that loss of energy, one feedback circuit or one compensator circuit is provided here, okay, or in the system. That compensator or feedback circuit provide compensate or feedback to the input again, and then the input or the those losses were uh, avoided, okay. So it uh, so here are the two sinusoidal type of sinusoidal oscillation, okay. Now let us see the oscillator circuit. That is, this is the previous one is the theory. This is the practical circuit which oscillate or how oscillate. Let us see, okay. Now what is oscillator circuit? A circuit which provide electrical oscillation of any desired frequency is known as oscillator circuit, okay, or tank circuit, okay. Now you see this circuit, okay, a simple oscillator circuit consists of a capacitor and an inductor in parallel as shown in figure. This is the oscillator circuit, okay, remember this, okay. Oscillator circuit, a general oscillator circuit is consisting of one inductor, this is inductor L, and one capacitor, this is C, in parallel to each other, okay. So this is the basic construction diagram of block diagram of oscillator circuit, okay. Now uh, now to understand how this come about, suppose the circuit, okay, suppose the circuit is charged from DC source, okay, with a polarity as shown in figure. Let's say this DC, let's say this capacitor charged by a DC source, and the polarity of the capacitor is positive here, negative here, okay. Now the first one is the in the position shows in the 7.2, the upper plate of the capacitor is deficit of electrons, okay. Since this is a positive, so there is a deficiency or there is a shortage of electron here, okay. And the lower plate has excess of electrons, since the lower plate is negatively charged, negative polarity, so here electron amount of electron is high, okay. So therefore there is a voltage across the capacitor, okay. So the capacitor, since this is a positive and this is the negative voltage source, in previously I told you that the voltage source is what, the potential difference is called voltage source. So here the potential difference is there, here electron is high, number of electron is high, here number of electron is low, so there is a voltage source produced here, okay. And that capacitor and the capacitor has electrostatic energy, okay. So the capacitor has electrostatic energy, okay, due to that voltage created in the capacitor, okay. Now when switch S, okay, before the switch S is open, okay, then after charging the capacitor by a voltage source and the capacitor have a voltage source, then after the switch is closed, okay, then the capacitor will discharge through the inductor, okay. This the capacitor having the charge, that charge discharge through the inductor, okay, and discharge through the inductor, and the electron flow will be in the direction of indicated by the rho, this flow, okay. You know, electron flow always negative to positive, okay. That means where the electron amount of electron is more, that is in negative end, and the amount of electron is less, that is positive end, more electron end to less electron end, that electron flow, okay. So the current direction should be in this direction. You see, this is the current direction, okay. Now the current flow set of magnetic field around the coil, okay. You know, whenever in a coil or through a coil, whenever the current pass through a coil, okay, in that coil one magnetic field is created, okay, which is called electromagnetic effect, okay. Then here also one magnetic field is created inside the coil, okay, due to the inductive effect, okay, the current building up slowly towards a maximum value, okay, and the circuit current will be maximized when the capacitor is fully discharged, okay. At this instant, electrostatic energy is zero, but because electron moving is greater, the magnetic field energy around the coil is maximum. This shows in figure 2, okay. Obviously the electrostatic energy across the capacitor is completely converted into magnetic field energy around the coil, okay. Now the third one is, once the capacitor is discharged, fully discharged, okay, the magnetic field will begin to collapse, okay, and produce a counter EMF. EMF means electromotive force, okay. Then EMF according to the Lenz's law, okay. The counter EMF will keep the current flow in the same direction, okay. That the result is that the capacitor is now charged with the positive polarity, okay, making upper plate of capacitor negative and the lower plate of capacitor as shown in figure, okay. Now after the collapsing field has uh, recharged the capacitor, and the capacitor now begin a discharge current. Now flow of direction is this, okay. So the circuit fully discharged, okay. So here here you see what happened in overall. I'll tell you that here what happened. Let's say here this capacitor first charged by external source, okay. Then the polarity, this is positive and this is negative, okay. So due to this and after that the switch is closed, the switch is closed, okay. So the voltage created in the capacitor is transferred or discharged the capacitor through the inductor, okay, and the current flow in this direction. Due to this positive and negative, the current flow in this direction through the inductor, okay. Now due to this current flow inside through the inductor, a magnetic field created, okay, like this, a magnetic field created in the inductor, okay. Now due to that magnetic field, one back EMF is, and no, whenever that magnetic field created and after fully discharged, okay, after fully discharged of the capacitor through that inductor, the magnetic field after fully discharged, the magnetic field disturb, and that magnetic field, due to that disturb, the one back EMF is created, okay, by the inductor, okay. And that back EMF is uh, making a current or building a current which flow in the same direction, means this direction, okay. Here this direction, here also this direction, okay. So due to this, the capacitor again charged. Remember, uh, this due to this back EMF produced by the coil, okay, that EMF charged the capacitor again, and the polarity is opposite due to the current flow this in this way. So negative here, always remember the current flow from negative to positive, okay. So negative here and positive here, okay. So the polarity will be polarity is changed. Here mean previously this is positive and negative, here this is the opposite polarity, okay. And due to that opposite polarity, again the current again the due to this switch is also always closed, again one current is produced or thus capacitor after and remember that capacitor charged whenever this capacitor fully charged, okay. Then after that capacitor want to discharge again, okay. And when the capacitor is want to discharge, then one current is flowing through that inductor, okay. And at that time the current flow in the opposite direction of the opposite direction of the fast current. Okay, fast current is flowing this direction, here this direction. Okay, so again the one magnetic field is created, and after that, after one magnetic field is created, and after that the sequence is repeated again and again and again. Okay, now the sequence of charging and discharging result in alternating motion of electron or an oscillating current. Okay, and the energy is alternately stored in the electric field of the capacitor C and the magnetic field in the inductance coil L. This interchanging of energy between L and C is depart over the again result. Okay, and the uniform is like this. Okay, sorry, the waveform is like this. Okay, this, and this is the waveform of damping oscillation. Okay, now the frequency, remember the formula, remember this formula, the frequency of the oscillation. Okay, this is the frequency of oscillation, here 1 by 2 pi, okay, into L and C. This is the inductance of the coil, and this is the capacitance of the capacitor. Okay, remember this. Okay, this is all about your oscillator and oscillator circuit. Okay, thank you.